Hello, welcome back. This is another measurement video. This time we're looking at Simpson's rule. Simpson's rule is used to find the approximate area of an irregular shape. When we say an irregular shape, one that's got lots of little squiggles everywhere, one that's not a traditional shape like a rectangle or a triangle or anything like that. And we use this rule to find an approximate area. So here's a squiggly little shape here. It's a bit like a rectangle, but not exactly. And we're going to use the Simpson's rule to handle an approximate area of this. Now we've put a few lines here. I'll put the lines up and then we'll talk about them. These are sort of, I guess, reference lines here. I like to think of these symbols here, DF, as like the first distance that we're using. This is the middle distance, halfway between, that we're sort of taking a bit of a measurement of, and a last distance. So first distance, middle distance, and last distance, and we'll indicate that by DF, DM, and DL. They're just sort of measurements we're taking at the beginning, the middle, and the end there. That's going to help us. We need those values for putting into the rule in a minute, substituting into the rule. And we're also going to take good care that we are taking those measurements at regular intervals. So the distance between our first height and our middle height will be the same distance across there as the middle height, and between the middle height and the last height there, the last measurement. So they're kind of like, it's a bit like a prism here. We're calling them H, but they're really widths. They're really crossways measurements most of the time. So they're the sorts of items we'll need for substituting into our Simpson's rule. So that's the first measurement, the middle measurement, and the last measurement, and that's like the width of each strip that we've taken measurements of. We've kind of got measurements for two of the strips that are chopping this irregular shape up. Alright, so the Simpson's rules is based on this. We've got the H, we put that H value, how far across each strip is here, and we stick it into the top of a fraction that's out the front of the first, and the middle, and the last. And you notice we multiply the middle measurement by 4. That's kind of because that in many shapes that middle measurement is a better, more accurate sort of average measurement of the overall shape. But anyway, that's the way it works. Let's have a look at an example that might help a fair bit. Okay, now here we've turned these into actual measurements here. We've got 6 meters for the first measurement, 10 meters for the second one, the middle one, and 9 meters for the last one. And we're taking those measurements 8 meters apart. Now each of those numbers will go into our Simpson's rule, be substituted in, and we'll see how we go from there. So can you see what our H should be? Our H is the width of each strip. So that'll go on the top there. We found that by these bits here. They're our H numbers. That's the width of each strip, goes on there on top of the 3. In the brackets, our first measurement was our 6, which was here. Our 4 lots of our middle measurement. Can you see our middle measurement is 10, this one here. So it goes into the DM bit there and gets multiplied by 4. And the last measurement is our 9. Let me circle that for you. So we're just taking each of those measurements, putting it in the right spot or under the right spot in our substitution into the Simpson's rule there. Now that can be done on our calculator, and we get an area of 146.6 repeater meters squared. Now we are finding an approximate area. So that explains why we've got meters squared here as our units. Our original units were meters, but we're finding an area, so that's meters squared. And we've got 146.6 repeater from just typing all those numbers into the calculator there. And we have to remember that it's an approximate area. You can see all these little squiggles around this shape here, even a couple of bits outside the measurement here. It goes down here in a squiggly sort of way. So that's always going to be just an approximation of the area, because we can only approximate it because the shape is irregular. Alright, now that's us taking measurements, breaking this irregular shape into 2 strips. It would be more accurate, we must admit. To improve the approximation of this area, we can take more strips. The rule can be applied twice or even more than that. If we apply it twice, we can apply the rule once to the first half of the shape and again to the second half of the shape and take a few more measurements. and that will help us with our accuracy before we add these two areas together. There's an example coming up. So instead of this shape here and leaving it as two measurement strips here with the numbers that we gain from those measurements being plugged into the formula, let's have a look. We can keep our 6 and our 10 and our 9 from the original. We've taken, in our bottom diagram here, we've taken two more measurements. One here and one here. And by taking those measurements, we can apply the Simpson's rule to the first half and to the second half and add them together and make it much more accurate. Notice how our width of our strip here was 8. We're taking twice as many measurements here, so the width of each strip for our Simpson's rule is going to be 4 this time. So by taking more measurements, we're going to get a more accurate, hopefully, more accurate approximation of the area by applying the Simpson's rule twice. Now this left-hand side is our first application of the Simpson's rule. We're putting in 6, 11, and 10 for our values here, here, and here. And we've had 4 for the height, or the width of each strip in this case. So this represents the first half, this section here, of our shape. So we'll figure that out as 80 square meters. Now the second half here, we're going to put some values in that indicate this second application of the Simpson's rule. Can you see that we're using 10 and 10.2 and 9? So this is our right hand half, if you like, that we're calculating out. And once we find the area of that section as 79.73 repeater, if we add those two together, we'll get the total of that irregular shape and get a more accurate approximation. So we get 159.73 repeater meters squared in total. So this section here, just to recap, that section there is the calculation of the Simpson's rule applied to the first half, and this section here is the area calculation when we applied the Simpson's rule a second time to the second half, and when we add them together we get a total area there. You'll notice that in an interesting way, this 10, that measurement for the middle section there, was actually used in this bit as the last measurement, and this bit here as the first measurement for the second half as well. Alright, so that gives us a slightly different approximation of the area. We've got to acknowledge, though, it's still an approximation. It might be a better approximation than only having one application of the Simpson's rule, but it's still an approximation nonetheless. Alright, so that's two lots of the Simpson's rule applied and added together. Here's a little twist I wanted to alert you to, because in some questions it looks like you don't have enough values. Now first, the width of each strip is clear there, 18 millimeters, and the first measurement is clear there, 12 millimeters. This middle measurement is there. Doesn't look like we've got a final measurement here. Doesn't look like we've got a height over in this section here. So how do we treat that? I wanted to alert you to the idea that we can put in a value of 0 meters for our last measurement there. So that's how you do it. You don't stress out that you haven't got enough numbers. Let's just acknowledge that that hasn't got a height right at the end there, so we'll put it in as 0 meters for our final measurement. Okay, so that's just for those questions whereby it looks like you don't have a value. If it looks like there should be a value there but it doesn't have a height at all, just put in 0. That 0 there will go under here in our calculation. We'll have 12 millimeters for that first value, 4 lots of the 16 millimeters. Our H here, our height, is actually our 18 millimeters, but we can process 0 for our final value there. Don't be worried about that. It'll still give you an approximation of the area of that irregular shape. So that's just to sum up. That's Simpson's rule. Pretty complicated it looks like at first, but once you get the hang of putting the right values into the correct spots just under the formula, it's a formula-based rule. So you write out the formula on one line, and I'd encourage you to find the right numbers for the right spots for the second line. Substitute all the numbers in, let your calculator calculate it all out for you, and you'll be using square units every time there because it's an area that you're finding. Alright, Simpson's rule. Hope that helps. PeterBlakeMaths.com. Catch you next time. Thanks for listening.